Hello students, in the given question, if N2 gas is bubbled through a water 293 Kelvin, how many millimoles of nitrogen gas would dissolve in 1 liter of water? Assume that N2 exerts a partial pressure of 0.987 bar. Given that Henry's law constant for nitrogen at 293 Kelvin is 76.48 kilobar. Right. So this question is completely depend upon the Henry's law equation. This one, once you observe here, so if N2 gas is bubbled through water at 293 Kelvin, how many millimoles of nitrogen gas is would be dissolved in 1 liter of water? So according to the Henry's law, so what is the formula? P equal to, as per the Henry's law, the formula will be partial pressure equal to kh into zeta, right? So here we are talking about the which one? Nitrogen gas, that is the zeta n2, right? Partial pressure of n2. So based on this, if you will calculate the, they have given the in this given data, so partial pressure of n2 they provided how much? Partial pressure of n2 already they mentioned 0.987 bar. So, and they have provided the which one? The Henry's law constant for N2 is the almost 76.48 kilo bar. You can convert into this one also in bar, this one also converted. Henry's law constant also need to convert into bar. KH equal to 76.4 kilo bar. They mention you convert into किल इंटू 10⁻³ करेंगे तो किलो, किलो को, सो 76.480 bar. So both are in pressure and as well as, right? If based on this data, if you will submit in this equation 1, so these two values, so zeta n2, so if you will observe, zeta n2 equal to pn2 by kh. If you will substitute these values, so P and partial pressure of N2 is 0.987 by 76,480. So this values approximately is going to come 1.29 into 10⁻⁻⁵. I calculated this value. I calculated this value. So I calculated the partial pressure of N2. Partial pressure of N2. So based on by using this partial pressure, the question is that nitrogen gas, how many millimoles of N2 gas would dissolve in 1 liter? How many millimoles? So you are talking about the millimoles of the gas. We are talking about the millimoles of the gas. So the partial pressure, the mole fraction of the gas equal N2 equal to, formula will be number of moles of N2 by total number of moles of N2. It is a mole, it is dissolved in water. That's why we need to calculate number of moles of H2O also we need to take. So number of moles of N2, if you will see, X zeta, number of moles of zeta N2, we know that this is the total number of moles. This is the mole fraction. So we know that in gases, the dissolution of gas is very less in which one? The dissolution of gas in water very less in dilute solution. So the number of moles we will not consider. That's why. So number of moles of N2 plus number of moles of H2O is approximately equal to the number of moles of H2O value को बराबर होता है, क्योंकि इनका वैल्यू very less होता है. That's why we are almost all we are making that number of moles will dominate by which one? Number of moles of H2O only, solvent only. So based on this, zeta N2 equal to number of moles of N2 by number of moles of H2O only we are going to consider. Clear? Now, if you will observe here, the zeta N2 value already we calculated from here. So that is, if you will put it those values, 1.29 into 10 to the power of minus 5 equal to number of moles का formula क्या है? Weight upon gram molecular weight. So weight of, right, we need to calculate, we need to weight of NH2O. If you will observe here, number of moles of H2O, if you will observe here. So weight upon which one? Weight upon gram molecular weight. Weight of the water will be already, it is here mentioned, 1 liter of water, it is N2 gas is dissolved. 1 liter is nothing but 1000 grams. So that is, we are going to take 1000 gram. My molecular weight of the water is 18. So 1000 by 18, it will give the 55.55 moles. The value will give. How much value will give? 55.55 value they will give. So zeta N2 value is 1.29 into 10 to the power minus 15, and number of moles N2 by the 55.55 moles. So if you will the number of moles, if you will substitute, if you will calculate, number of moles is equals to 1.29 into 10 to the power of minus 5 into 55.55 moles. If you will multiply, the answer will be approximately, it is going to become 7.16 10 to the power of minus 4 mole. It is in moles, it is going to become. But in the question they asked the nitrogen, how many millimoles of nitrogen gas, how many millimoles of nitrogen gas would dissolve. So they asked the question in millimoles. So that's why this given number of moles, this moles we need to be converted to the millimoles. So if you will convert into millimoles, convert into millimole, that means it is going to become, so 0.716 millimole it will come. So the answer will be, so how much gas will be dissolved in millimole? 0.716 gas will be dissolved in 1 liter of water. So this is the answer. Thank you.